welcome to this session. This session, we want to prove some problems on determinants. So the first question is to prove that a squared, the determinant of a squared a, b, c, b squared b, c a, c squared c a b is the same as negative determinant of 1, 1, 1, a squared b squared c squared, a cubed b cubed c cubed. And then the second question, expand without expanding and or evaluating, show that the determinant of a squared a 1 b c d, b squared b 1 c d a, c squared c 1 d a b, d squared d 1 a b c is equivalent to the determinant a cubed a squared a 1, b cubed b squared b1, c cubed c squared c1, d cubed d squared d and 1. So we are going to make use of the properties we have listed in the previous class to be able to prove these results. So proof. So the first problem is to show that a squared a b c b squared b c a c squared c a b is equal to negative the determinant of 1, 1, 1, a squared b squared c squared, and then a cubed b cubed c cubed. Now, we have to start with the left-hand side, applying the properties of determinants and show that it simplifies to the solution we have on the right-hand side. Now, if we observe these elements of this determinant, then you see this third column, this is BC, this is CA, this is AB. So one key thing that we observe in this question or this element is that all elements here are formed by 3 letters, A, B, and C. So what you can do, if we check the third column, we see this BC, A is missing, CA, B is missing, AB, C is missing. So we can say multiply, let's so let row 1 be A row 1, let row 2 be B row 2, and let row 3 be C row 3. Then we have that this determinant A squared B BC B squared B CA C squared C and AB. Now, when I multiply the first row by A, so I'll have A cubed, and then AB, and then I'll have A, B, C. But you see, I have introduced a factor A to this row. So to have the original determinant being maintained, I have to divide by 1 over A so that the original determinant doesn't change the value. Because remember we said, if you have a scalar multiplying any row of a column, then the determinant is simply that scalar multiplied by the original determinant before multiplying the scalar to the row. And then I multiply b by row 2, I'll have b cubed, b squared, and then I have, I remember this this was 8, so this position is 8. So this position is a from the original determinant, so this is a squared. Now, if I do multiplication of b by second row, then I have b cubed, b squared, then a, b, c. But because I've introduced a factor b so that I don't change the original matrix, so that I don't change the original determinant, I have to balance it by dividing by 1 over b. So b. And then third one will be c power 3, c squared, and then a, b, c. And because I've introduced a factor c so that I don't change the original determinant, I have to balance by multiplying by 1 over c. So this is what we have. Now, this would be the same as, now you see this determinant now here, this third column has a common factor a, b, c. So then I can pull out that factor and then I maintain this column with ones. So our next statement will be, I have a, b, c. I then pull out this common factor, a, b, c, and then we'll have a cubed, a squared. Now this will be 1 after factoring out a, b, c, b cubed, b squared, 1, and then c cubed, c squared, and then 1. So that's what we have. And you see a, b, c over a, b, c just 1. So it'll be a cubed, a squared, 1, b cubed, b squared, 1, c cubed, c squared, and then this is 1. Now, you see, if we interchange column 1 and column 3, so interchanging columns 1 and 3, we have, so remember, whenever you interchange any columns in a determinant, then the sign changes. So I'll have negative, then 1, 1, 1, a squared, b squared, c squared, and then a power 3, b power 3, c power 3. And then next step now to get what the right hand side is. So this first row should be a 1, 1, 1, a squared, b squared, c squared, a cubed. So cubes on the third row. So simply now transposing this determinant we have, now remember, when you transpose the determinant, the sign doesn't change, it's the same. So I'll have first column becomes first row, second column becomes second row, and third column becomes third row. So that is what we have, and that was what we were to prove. And then question 2. So the left-hand side is given by a squared a1 b c d. We have b squared b1 c dA, and then we have c squared c1 dAB, and then we have d squared d1 ABC. Now we do the same game we have done in the previous one. You see, these elements of this 4x4 determinant are actually formed by 4 letters, A, B, C, and D. And when you check this fourth column, B, C, D, so A is missing, C, D, A, B is missing, D, A, B, C is missing, A, B, C, D is missing. So then we say, let us say that row 1 to be A, row 1, row 2 to be B, row 2, row 3 to be C, row 3, and row 4 to be D, row 4. I remember we'll be balancing by dividing by multiplying by the reciprocals of A, B, C, and D, so that we don't change the original determinant. So by that adjustment, so we'll have, so multiplied by A, we'll have A cubed, A squared, A, B, C, D. But because you have introduced a factor A here, so you have to multiply by its reciprocal so that you don't change the value of the original determinant. And then this will be B cubed, B squared, B, and then A, B, C, D. You have introduced a factor B, so you have to multiply by its reciprocal so that you don't change the original meaning of the determinant. Next, we'll have C cubed, C squared, C, and then A, B, C, D. You also have to multiply by the reciprocal of C so that we don't change the original determinant. And lastly, D cubed, C squared, D squared, D, and then A, B, C, D. Also, you have to multiply by the reciprocal of D so that you don't change the original value of the determinant. Now with this, you see that this fourth column has A, B, C, D throughout. So we can factor it out and multiply by the resulting determinant after factorization. So we'll have A, B, C, D divided by A, B, C, D, determinant of now, after factorization, this column will be 1, 1, 1, 1. So we'll have A cubed, A squared, A, B cubed, B squared, B, C cubed, C squared, C, D cubed, D squared, D. So that's what we have. And that is the same as just this determinant because this will give us 1. So which will be the determinant of A cubed, A squared, A, 1, B cubed, B squared, B, 1 c cubed c squared c1 d cubed d squared d1. So that's what we have. And actually that is what we were to prove, that that determinant reduces to this fourth order determinant. So that's how we solve those two problems, applying the properties of determinants we learned in the previous class. Thank you.